So let us now look at 18th question of GATE 2018. In a Germany Enquence test of the Eutectic plain carbon steel, which of the following represents the sequence of microstructures observed from the quenched end of the specimen? And the microstructures given are martensite and perlite, fine perlite and coarse perlite. We need to find the correct order of microstructures from the quenched end of the specimen. Here the schematic of Germany Enquence test is shown. Germany Enquence test is a method that is used to determine the hardenability of the steels. In this test, a steel rod of 1 inch dia and 4 inch length is heated to proper austenitizing temperature. After held at that temperature for a specific time, it is being held to a fixture as shown in this figure. The water jet is then opened quickly and cooled from the bottom end of the bar, and the sample will be subjected to microstructure analysis, and they used to find the distance d at which exactly 50% martensite is there. So in this question we need to find the sequence of microstructure from the quenched end, that is from bottom to top. From the schematic we can say that the cooling rate will be highest at the bottom end, and as it approaches towards the top the cooling rate decreases. Let us now look at continuous cooling transformation diagram of Eutectic steel. So at the quenched end, once the sample is cooled from the austenitizing temperature, the cooling rate will be higher than the critical cooling rate. So the microstructure formed will be completely martensitic as shown in the CCT diagram. So considering this as quenched end, this region will be 100% martensite. So on moving away from the quenched end, the cooling rate decreases as shown in the second curve. As we know in CCT diagram, this curve represents the start of perlite transformation, and this curve represents the end of perlite transformation on continuous cooling. As the cooling rate decreases below the critical cooling rate, perlite starts forming, and on complete transformation, the microstructure for the second cooling curve will have both martensite and perlite. And on moving further from the quenched end, the cooling rate further decreases and the curve goes beyond the end of perlitic transformation. So both the curves 3 and 4 will have 100% perlite. And as we know, when the cooling rate keeps on decreasing, the chance for diffusion of ferrite and cementite in the perlite phase will slow down, resulting in coarser microstructure. So fine perlite will be formed first, followed by coarser perlite. So the correct sequence of microstructure from the quenched end will be martensite plus perlite, fine perlite and coarser perlite. So the correct answer is option B.